Hello everyone, welcome to the OneClass channel. My name is Millen and I am a software engineering student at Carleton University in Ottawa, Canada. Today I'll be going over a couple of physics questions at both the high school and university or college levels. If you're interested in getting help with your homework or if you're interested in getting some tutoring, check out the links in the description below. Cool, so let me switch my screen real fast and we can see the physics in action. Okay, so this is the first question that we got on the menu today. It is asking us the angle between the vector A, which is negative 25 in the I direction and 45 meters in the J direction. We have to find the angle between that vector and the positive x-axis, okay? This is a fairly straightforward question. Let's draw a diagram out to kind of represent what this question is really asking us. Okay, so let's draw out a little coordinate grid system like this. That's a pretty good straight line for freehand. So here we have our y-axis. Here we have our x-axis, and here we have our I, and here we have our j, unit direction vector. Okay, so vector A, let's say A is like an apple, so it's red. A is going negative 25 in the I direction. Okay, so suppose that we have maybe like this. Negative 25 meters in the I direction, and we have 45 meters in the J direction, which is the Y direction. And that's positive, so following this type of protocol, we have something like this, 45 meters. Okay, so this vector is going to go from the origin to here. Okay, let's call this vector A, which is negative 25 meters in the I plus 45 meters in the J direction. So the angle that we're really interested in is this angle right here. And as we can see from the diagram, we expect something that's going to be bigger than 90 degrees, but smaller than 180 degrees. Okay, so just visually from the diagram, we know what that is going to be. So one way that we can solve for this angle is with the magic of the dot product. Okay? So remember, oops, let me find my mouse real fast. So our dot product formula looks a little bit something like this. So when we have two vectors dot producted together, the result of that is the magnitude of the two vectors multiplied together, which is represented like this, and the absolute value means the magnitude of the vector. So when we have that, we multiply it by the cosine of the angle that separates them. And this is like the main dot product formula that we want to keep in mind. Now we know that A is going to be negative 25I plus 45J. And what do we want to compare? What do we want to set as our B? Well, it's saying the positive x-axis, right? So for our B, we can just do I. So this corresponds to positive x-axis vector. Okay, so when we have a system like this, you know, we're really looking for the angle between them. So if we want to isolate the angle, then we're going to do the dot product of A and B divided by the magnitudes A, B. This will give us cos of the angle, and we just got to inverse cos both sides to get the to get the theta out of the cos. But we'll leave that in for now, just so it's going to be a little bit easier to write. Okay, so let's actually write out what this is going to be. Oops, let's put that away. Cool, so I'll write this out very formally. So here we have the vector negative 25i plus 45j dot product with just I divided by, well, the magnitude of a, we know that we have to do negative 25 squared plus 45 squared. Very Pythagoras-like. For the magnitude of b, well, that's fairly simple. It's just going to be 1 squared under the root. I'm going to write it out still just to be 1000% formal. And this is going to be equal to cos theta. Okay, so carrying on with this calculation, on the top we'll have negative 25 multiplied by 1 plus 45 multiplied by 0. Right, that's the dot product on the top. On the bottom, we will have 25 squared is 625, I believe, plus 45 squared. So this is the square root of 2650 times 1. I guess we'll write that there just to be 1000% clear. Cos theta. Okay, so on the top, as we can see fairly clearly, this is just going to be zeroed. So we don't need to worry about that anymore. Now it will just be negative 25 over the square root of 2650. And the square root of that is 51.478. And this is equal to theta if we cos inverse arc cosine like this. Okay, kind of see how this works. To get the theta out of there, we got to inverse cos both sides. Okay, and then we shall ask the calculator to figure that out for us. So negative 25 divided by 51.478. Boom. So the result of this calculation for me is 119 degrees, approximately equal. There's a lot of decimals that I'm not going to write out because that is a lot of decimals that we need to keep in mind, but it's about 119 degrees. Yeah, it seems fairly reasonable. Like, it is between 90 and 180 as we expected. It's going to be a little bit closer to 90, which it is. It's about 30 degrees away from 90. And just visually from the diagram, we can see that it actually does look like it could fit, because it would just be 30 degrees counterclockwise from the vertical. So it does seem reasonable with respect to the diagram. So the number feels reasonable. It looks reasonable visually. We got to have the right answer. So hopefully we came to the same conclusion here. 119 degrees. That's beautiful. Cool. So, and that's the angle that it makes with the positive x-axis. That's precisely it. Okay, so that's the dot product for you. Dot product is very, very useful when you want to find the angle between multiple vectors. Okay, so yeah, this is good. Awesome.